Okay, so I figured I'd start out just by introducing myself. So I'm a developer at Oklahoma Heart Hospital. I'm also a self-taught developer, so I kind of like learned on the job and was given the opportunity to, like build applications and things like that while also learning, which I guess we're all sort of learning and stuff like that. But so I give that as encouragement to anyone who is self-taught or currently teaching themselves. It's definitely worth your time. It's such an amazing profession that we get to do, and so I can encourage you to continue in that. So I want to start out by saying that there's different levels of sort of familiarity with code and stuff like that in the room. That's probably true at all of the CodeCamp meetings, and so if there is anything that you want to have clarified or that might be a little over your head, take notes on it, ask us about it later. The beauty of being like in-person groups is that you can ask questions and get immediate feedback, so everything else you can take notes on and go to the myriad of resources that are online to go further in whatever that particular subject is. So I will get into some things that are like slightly more classified as intermediate, you could say, but those will just be concepts that you can, like I said, go back and research later. So what is JavaScript? JavaScript is a scripting language ran in the browsers or some other type of engine. So the distinctives is that it is ran by browsers in order to make websites sort of dynamic and interactive. That's kind of the first use, the first case of JavaScript and why it was developed. So it's similar to Java in syntax. Some people might have quibble with that, but there was a lot of inspiration that came from Java syntax. But I don't want to say that and people think that JavaScript is purely an object-oriented language. If that term is familiar to you, it's just a programming paradigm. Some languages strictly follow a programming paradigm, and some languages don't. JavaScript is one that does not strictly follow some sort of programming paradigm. So you'll see all sorts of functional and declarative concepts in the language, and then you'll also see some object-oriented concepts in the language as well. The JavaScript is interpreted, which means that the browser or whatever engine is running the JavaScript will interpret it at runtime, and it is by that token it is dynamically and loosely typed. So all that means is that what the language or the engine is expecting is evaluated at runtime, and we'll get into some more examples that I hope will kind of solidify that. But first, why JavaScript and why is it important? And especially as people who are getting into code, if you're new to learning or if you're learning just a new language or wanting to know more about JavaScript, the reason that it's important is because virtually all front-end web technology is run by JavaScript. There are alternatives to JavaScript in terms of strictly the front-end scripting in the browser. However, a lot of those either transpile or compile to JavaScript, and so it's really kind of the foundation of front end. Nowadays also JavaScript can be learned, and you can be virtually a full stack developer by learning just JavaScript. So you can learn JavaScript and learn the Node.js framework, and that is a server-side framework. And then you can also use it to port over to different mobile apps. There's all sorts of different levels at which you can take JavaScript code, port it over to a mobile app. You can do it in desktop apps with a framework called Electron. So it gives you a lot of power. And if you're wanting to get into learning code, I highly recommend learning JavaScript nowadays. Web technology is definitely where we're at in terms of the primary paradigm that we're using, and JavaScript just gives you a lot of power behind that. And so it's definitely a great first language. What I will say about JavaScript, and it kind of goes back to the paradigm that I mentioned, it doesn't follow a paradigm. JavaScript, to me, I describe it as it's easy to learn but difficult to master. There's so many different design patterns within JavaScript. There's so many different ways to skin the cat that sometimes it can muddy the waters. And I think that will, I experienced that even making these slides and making this talk because, for instance, right now, a little bit about where JavaScript is at. JavaScript is in between the ECMA script standards. So ECMA is the standardized implementation of JavaScript per browser. As we know, there's all sorts of different browsers. Some are better than others. And so each browser will implement it differently. But they have to follow, each browser has to be ECMA compliant as well. So with ES5 is the most standard way. When you see JavaScript code, it's most likely ES5, ECMA script 5. And that just has to do with the syntax and some of the functions that you'll, not functions, but some of the syntax that you would use in order to solve a particular problem in JavaScript. Overwhelming majority you'll see is ES5. However, I introduce a lot of ES6 sort of examples in this presentation. The reason for that is because I recommend that if you are learning JavaScript right now, because the industry is between ES5 and ES6, and really we're more on the ES6 side than anything. There's just some browser support. Like in my job, we have some browsers that don't support ES6, so I have to write in ES5. And so I just recommend being familiar with both because you'll see documentation that's both. You'll see old code at work that is both if you get to work in our profession as programmers. And but ES6 is, in my opinion, a lot better moving forward, and definitely the concepts that they have built around is where the language is going, so that it'll be better for the future. That's kind of a lot, but I think, like I said, we'll see some code examples. The majority of my talk is code examples, so I hope that you kind of see the differences in there. Okay, so in a language, you obviously have different data types. This has to do with the data that you're passing around and manipulating in your program. So in JavaScript, you have pretty standard data types. You have strings, numbers, booleans. You also have the undefined data type and the null data type. And then you have objects in JavaScript, which you have object literals, which are objects which you can place different bits of data. We'll see an example of that. Arrays and functions are also operate as objects. And the function as object in JavaScript is an important concept. Function, of course, is some sort of subroutine that you can declare and define what's going to happen and then call that later. It's the best way to keep yourself from repeating code. And so in JavaScript, because a function can operate as an object, you can both assign it to a variable and also pass it as a parameter. And we'll see plenty of examples of that today. So I'm actually going to flip over to some code examples real quick. Refresh that. So one of the things that I mentioned earlier was that JavaScript is both dynamically and loosely typed. What that means is that whenever it's interpreted, whenever it's going through and being evaluated, you can both change the data type of a particular variable, and it cares about its declaration, but I'll show this right here. So here I have just a simple variable. I've declared it with the var keyword, which is, I'm declaring a variable and just saying, hey, here's a variable, I'm going to use it. In a lot of implementations of JavaScript, it will assume that you're declaring it if you assign it. So if you up here did something like num equals 0, it will go ahead and declare that, but that is not best practice. Variable declaration is one of the easiest ways to just keep your code simple and avoid bugs. So it's always good to declare and also keep up with your data types. A lot of the stuff about this type conversion that we're going to talk about here, it can get really messy and it can do more harm than good. So although it's convenient, you also have to be disciplined as a programmer as you're writing it. So this is not something that, there are a lot of languages, Java for instance, if I were to declare num, I would have to say both that its value is 0 and also that I'm declaring it as an integer. In this case, with JavaScript, I don't have to do that. I can just say, hey, I'm a variable and I'm going to use it. So another thing about JavaScript is awesome. You can just pop open a console in a browser and run code. Chrome has a great console, and that's what I'm using here. So I'm just going to paste this in. And as you can see, so the first thing I do is I declare the variable. I declare it num. I then assign it a value of 0. And you'll notice what I do next is I actually use the plus operator to add and assign to that variable another value. because JavaScript is loosely typed, it's going to try and figure out what my data type is. And so it's essentially saying to itself, hey, they're trying to assign a string to this value that I already have. And so instead of adding it together, which you can use the plus operator to do with numbers as well, I'm going to concatenate it. And so you'll see here it says 0 test. So then what it does is it converts the 0 to a string and then concatenates the word test. And then I can also reassign any other data type to num again. There's no limitation as to the data types that I can use for that particular variable that I've declared. Any questions so far? Just thought I'd ask. So yeah, so with again, it tries to find the right data type that you're using. That again can be super hairy and introduce a lot more bugs than it actually is convenient. And so my encouragement to any developer working with JavaScript or a loosely or dynamically typed language is be disciplined with your variable declarations and keep up with them. Even evaluating using the type of operator, you can. If I wanted to know what something was, if I declared that same variable, I can use type of and figure out what the type is. So just being disciplined whenever you're evaluating variables, making sure that you know what the data type is. So I have a couple other examples here. What this actually implies is that whenever you are evaluating some variable, you can evaluate it based on value, or you can evaluate it based on value and type. So we have, in JavaScript, it has a double equals and a triple equals. Single equals is always assignment, so that means that you're assigning something to that variable. And then double equals means that you're evaluating the value. So JavaScript will try to take that value and whatever you're comparing it to and say, okay, I think that this is what they want, and then give you back a Boolean value based on that. So in this case, I've declared a variable, not really a number, because it's not really a number. Yeah. Yeah. Just repeat what I said. Yes. The question was just what was I saying about the double equal and triple equal? So all I'm saying, and we'll see this with this example, but the double equals compares both the value, like the actual value that was assigned to the variable. Triple equals you can only use it, or it will only evaluate correctly or the way that you expect if it's both the value and the same type. So in this example, you can say not really a number is equal to a string that has the number 1. It's a string that says 1. If you use the double equals, this will actually evaluate as true. So we can put both these in the console, and I'll show you what I mean. So in the first example, I use the double equals, and what JavaScript does is it says, is it the same value? Is the string 1 the same value as the number 1? And so it converts the type of the first one to what I'm comparing it to, and says, okay, yeah, they're true, or it's true, so it returns true, and the if statement then evaluates. In the other example, what I've done is I've compared it with the triple equals, which requires that it be of the same value and the same type. So whenever I evaluate that, it returns false and goes to the else part of the logic and says evaluated false. The reason being is because the string 1 is not the same type as the number 1, even though they're the same value. They're not really the same value because strings and numbers are different, but when it comes to the human readable format. Did that clarify what you were looking for? Yeah. Okay. The other thing with variables is that, and this gets into sort of the ES5, ES6 crossover, so I feel like this kind of muddies the waters, but again, I encourage you to do your best to learn both standards because it's helpful to know both because of all the documentation resources that are out there. So the different ways to declare a variable in JavaScript are using the var keyword. Historically, that's been the only keyword that's there. well, I don't think const was actually there. But either way, in moving into ES6, they introduced const and let. So the distinction between var and const is just simply that they are declared in the scope, which we're going to go over a bunch about scope here in a second. So they're declared in the same scope, but one is a variable. In other words, a true variable. It can be changed. It can be reassigned to a different value. Constant is a true constant. So JavaScript will yell at you if you're trying to reassign a different value to something that you've declared as a constant. The let keyword is a little bit different. It really just has to do with scope. So let is you are declaring a variable, so something that can change as your program evaluates itself or is evaluated by the interpreter. And the only difference between it and var is that var is function scoped, and then let is block scoped, which we will get into that in a second. So I'm just going to paste this in and we'll see. So you'll see that it gave me a type error whenever I tried to reassign something to the constant, which was right here. So I declared it up here. I said I'm a constant. I tried to concatenate something else on top of it, which means I'm changing the value. And then, of course, it yells at me because it's a constant. It's declared as a constant. And then var and let, they let me go ahead and concatenate more onto the current value. And so, but the only difference being is in scope. Again, we're going to get to some of that kind of stuff. There's one, I say little, probably major caveat to the whole being able to change with the const keyword. So with objects are just a structured data type in which they have different properties that can also be assigned to any other data type. So an object's property can be any of the normal data types. It can be a function, it can be a object, it can be an array, and it can be a string or a number. In this particular object, I've said const, I've assigned it to the variable O, or the constant O, and I've assigned these different properties to it, one of which is a function, one of which is an array. However, the thing about JavaScript is that objects in JavaScript are immutable. So that means that I can change it. Even though I've declared this object as a constant, I can change the properties of the object. There are ways to freeze an object. There's a method called object.freeze, which it comes in handy whenever you don't want that object to change any of its properties, any of the values of its properties. But I can say oprop1 is now test. So essentially I'm saying take the property 1 of the object that I just declared and change it to the word test instead of the number 1. And I can just log this back out, and now prop1 is changed to test. So whenever I say a constant declares a constant, it is true that it declares a constant, but with the case of objects, properties are still able to be mutated. Okay, so that covers that part of it. Any questions before we move on to some other concepts? Cool deal. So there's 4, I kind of like broke it down to these 4 concepts and said these are 4 concepts that are related, and it's kind of hard to just like go into one without going also into the concepts of the other. So I just kind of said, okay, we're going to talk about variables and functions. We've talked a lot about it already, but also we want to talk about hoisting and scope. These are some distinctives of JavaScript that are really, really necessary to know if you're going to develop applications and avoid a lot of bugs and those different types of things. So I'm just going to do that by going into some examples here. So in JavaScript, there is a function declaration and a function expression. So remember earlier I said that functions are objects, and because of that, that means that they can be assigned to a variable and then reused later. In this case, in most cases, you'll see that we declare a function by just using the function keyword. So we say, function, we're going to declare a function, you write your parameters, you write your code, and then later on you'll call that function just with the parentheses. So in the case of this one, I would just, if I wanted to call this function, I would say something like this, and that calls the code that I wrote in the function declaration. In the case of a function expression, one of the concepts in JavaScript is an anonymous function, so an unnamed function. There's two ways to do that. The ES5 way of doing that is by using the function keyword without naming the function. So in this case, I have an expression, I assign it back to the variable function expression, and then I can then use function expression just like I did the declared function with the parentheses. The ES6 way of doing this is using arrow functions. Now, I want to say at the outset that there is a practical difference between an anonymous function using the function keyword and an arrow function, especially if you get into more advanced JavaScript, if you get into React or any front-end framework that use classes or modules and things like that. It is important to know that there is still, even in ES6 and moving forward, a practical difference between the function keyword, anonymous function, and the arrow function. So in the other function expression using ES6 here, I have arrow function expression, and this is the same, it's just prettier syntax on top of this. So it's taking a function with the parameters of which is one string called message, and then I log that message, and now I can use that here. So I'm going to copy and paste this, just show an example. So, and then I can use that same variable again here. It's just going to log out whatever I've done. So there are different reasons why you would use a declared function versus a function expression. The function expression helps with the sorts of design patterns that you see in JavaScript. It's not important, those like decisions as to like which one should I use, those are very specific to whatever application you're using and what kind of, exactly what you're doing. So like I said, there's all sorts of ways to skin a cat in JavaScript. This just happens to be a couple of them. The other important thing that we need to understand whenever it comes to declaration functions and variables is scope. So there's 3 levels of scope in JavaScript. There's global scope, there's function scope, and there's block scope. And I'll show you all of these right now. So in the global scope, anything that's declared outside of a function or outside of a set of brackets is in the global scope. And so you'll see, because I'm at the top of my file here, I'm declaring this variable, global scope var, as it's globally scoped variable. Now I declare a function called scopeFunc, and I declare a variable inside of that function. Now what that's going to do is it's going to take that variable and it's going to define that variable, but only inside of the function. So I still have access to global variables inside my function. So whenever I log out global scope var, it's still going to log out just fine. I'm going to log out the function scope var. That's going to log out just fine because I'm still inside my function. I'm going to go outside of the function and invoke scopeFunc, and it will evaluate that code that is inside of there. But then I'm going to try and console log out this. This is perfectly fine because it's in the same scope that I declared it. However, function scope will throw a reference error because in the global scope, in the scope that I'm trying to log it out, there is no such thing as function scope var. It is inside of the function. So I can actually show that. So you'll see function scope var is not defined. And that is very important to know because with the advent of ES6, there is such thing as block scope. There hasn't really, in JavaScript, there's only historically been, you've only had to really worry about global scope and function scope. But now we are, you can use the let keyword to declare something that's block scoped. So in this particular example right here, I have this parent scope, so I'm outside of the block that I'm about to evaluate. And then I do a different one. I define a different variable inside of the block. And block is really just defined as anything inside of like the curly brackets like that. So if statements, for loops, anything that uses that syntax is considered a block. And so the block var will be perfectly defined inside of here. But if I try to console log outside of this block, then it will be undefined. In fact, I'm going to just, sorry. So you can see that in the final console.log, it comes back as undefined. Well, I'm using the type of to see that block var is undefined. If you try to console log out that, it'll do the same thing. It'll throw a reference error, just like in the last example. The other concept that goes with scope is called hoisting. So functions and then variable names are hoisted, which means that they're whenever the browser or whatever engine takes the code and starts figuring out what it's going to do, its plan of attack for evaluating the code, it's going to take function declarations and variable names and take them to the very top of the file. So what that means is that I can actually declare functions in areas other than where I actually use them. So for instance, in this case, you can see that although I am declaring the function below my invoking of that function, it works perfectly fine. The reason for that is hoisting. So it says, okay, they have this declaration, and so it throws it up to the top of the file, and then I'm able to use it anywhere. Now, I will say, yes? What would block scoping be used for? So block scoping the primary use case that I've seen is that if you have something like a for loop or something like that inside of a function, it just lets you create a cleaner separation in scope between what's going on in that loop and what's going on in the function. So obviously with like for loops and other things like that, you could be declaring a lot of variables inside of there that you're using just for that block. And so it's important that you have some way to be able to have that variable and not have it muddy up the scope of its parent scope. That's the main thing I've seen. I've seen people use it very interchangeably. I think that if you see documentation online, you'll see it be used very interchangeably with var if the scope is something that isn't necessarily concerned in that particular block of code. But I would just say it's always good to be cognizant of if you're using a block that you have that to your at your disposal to be able to use, and it helps avoid potential headaches. So that's a really good question, though. So remember whenever I said that you can both declare a function, but you can also assign it to a variable and create a function expression. In that case, it will not be hosted. The name that you of the variable that you assign it to, it will be hoisted. So it will have its definition, or not its definition, but it will be declared up at the top of the file, but it won't have the assignment of the function until it actually is evaluated in the sequence of the code. So in this case, you try to use this expression. It's not actually hoisted, so it will not work. It will be undefined. Then I actually assign the function, and then I can use it after that. So you can see on line 1, I can't use that. But now, after I've actually assigned it, I can use that. So in anything that you want to use the hoisting action of the function declaration, you have to use the actual function declaration method as opposed to an expression. Okay. Scope is very important. I'm just going to reiterate that. Scope is very important. That's true for all programming, so in JavaScript in particular, because there are so many different potential headaches that you could get into with that. So there's kind of like we're going on to something else. So with scope, variables, functions, function expressions. Are there any questions? Okay. So one of the things about JavaScript that also makes it unique is that JavaScript is single-threaded and it's asynchronous. What does that mean? So in programming, there's a distinction between synchronous and asynchronous. Essentially, all that means is when you're doing work, either you can do it in complete sequence, or you can do it in such a way where you say, you're essentially telling the browser, the engine in this case, okay, go do this. I'm going to do some other stuff while you do that. And so you have simultaneous work going on. JavaScript is asynchronous because I imagine it kind of being like a waiter. So if you're at a restaurant and you're trying to, get your food, so you put in your order, they go and they say, okay, cook, I need you to cook my order. So in other words, they're giving their work to a different process in this example. Then you don't want the waiter to be sitting there twiddling their thumbs just doing nothing. You want, your drink to be refilled. You want all sorts of other things to happen. So in this case, the advent of web technology has allowed us to be able to make web server calls and different things that the JavaScript process has no power over how long it takes or anything like that. And so they've developed JavaScript and implemented JavaScript in such a way that it's asynchronous. And so whenever I make a server call, which happens all the time, then I can still do work without that blocking the rest of my program. So one of the ways that we solve this practically in JavaScript is using the whole idea of functions as objects. So whenever we were talking about functions as expressions earlier, we were able to say, okay, I can assign this to a variable. The same concept is true whenever it comes to using a function as a parameter, which is something semi-unique to JavaScript, but definitely something that's well utilized in JavaScript. So we're just going to get into some examples of this because this can get, it's just easier to see, like most things, I guess. So I have several things to kind of illustrate this. So let's say that you have a function, and in this case, I have an interval. So set interval is just a function in JavaScript that I can have something do something at whatever time frame that I want. So in this case, every 1 second, 1,000 milliseconds, I'm going to console log that I'm inside this interval. And then outside of that, I'm just going to console log that I'm outside of the interval. But let's say that this is actually some meaningful work going on here. Let's say that my program has to go do some stuff, and while it's doing stuff, I am going to do some other stuff. So this is one of the beauties of JavaScript. So I declared it, now I'm going to call this function. So you'll notice that the first thing that console logs out is I'm outside of the interval. The reason for that is because, and interval is going to keep going until I clear it out. So what that's saying is I'm going to set this interval, and so after I'm doing some stuff, after a couple seconds, then I'll do the work. But JavaScript continues on to the next line. It goes to the next line, and console logs out the first thing that logs out is that I'm outside of the interval. So this is just kind of demonstrating the issue that I was just talking about. I'm going to refresh that because that interval will go on forever. And then now we'll kind of get into like how this could be more useful. Obviously, you're not going to set arbitrary intervals all the time, but it does show that JavaScript, by its nature, will move on to the next line even after you've initiated work on a different line. So one of the ways to solve this is by, like I said, using the function as a parameter, which we call a callback. It's essentially just a way of saying, okay, I'm going to do some stuff, and then whenever I'm done doing that stuff, I'm going to tell JavaScript this is what I want it to do with that. And the way I do that is by giving it a callback to call whenever it's done doing the things that I want it to do. This, I feel like, is kind of a bad example, but all it is it's showing that I can call this parameter right here that says callback is a function. So whenever I want inside of the parent function, I can call that as a function.
And that looks like this. So just to demonstrate the syntax, what I'm going to do is I'm going to call the count stuff then do stuff function. It's going to go through all of this code right here. And then whenever it's done, it's going to call the callback, which I've defined here with this anonymous function. And I'm expecting to pass data to it, and so I'm going to be passing this parameter to it, and then it'll console log that out. So this really doesn't do a whole lot, but so I'm inside that callback, and it's looping through. Okay, so I'm inside the for loop for several counts, and then I'm inside the callback, and it just passes what counter was counted to. So that's just illustrating the syntax of how you might pass something to a callback. Now, I mentioned earlier, too, that you can use the function keyword to declare an anonymous function, and you can also use an arrow function. We'll see an example of that here, which is, so let's say that I need to do some stuff with data. So I have this function declaration. I'm going to pass it a callback. Here, this is going to be the callback that I pass it, and then I can call it just like this. So I'm invoking the function go get data, and as it's called back, we're going to do the do stuff with that data function. So where does this really come into play? This really comes into play whenever we talk about how JavaScript is served to a browser by a server. Once it's there, it might need to go back to the same server or to a different server and grab more data or send more data or whatever it might need to do. So, and the way that we handle that is by using these callbacks to tell JavaScript, okay, whenever I make this call, use this function to evaluate this data that comes back or do whatever I want to with it. So there's two primary ways of making server calls in JavaScript. They're both available to you in the implementations in the browser. So the first is an object called XML HTTP request. So this is just an object that you invoke, and it gives you several methods to be able to send data and receive that data back, and then handle errors and different things like that. So it's a little, if you're not familiar with this type of syntax, it can feel a little overwhelming at first, but we'll kind of walk through this line by line. So what I'm doing is I'm declaring a function. The function's parameters are going to be a callback. I'm going to instantiate a new XML HTTP request, which is just the syntax of how you use this particular object. You have to look up the documentation on this object to know all the different things available to you, but this is one of them. OnReadyStateChange is just whenever the state of this particular call is changed, this is the function that I want to call. And you can see that here in this line, I've handled some potential errors, so I want it to be done, and then if it's done, then I'm just going to go ahead and use the callback that I passed into the function declaration. A lot going on, obviously, and then right below that I'm going to open, and that just means that you're defining the type of request that I'm making into what server, what URL endpoint, and then I'm going to send it. So in this particular case, I can paste this into the browser. What did I do wrong? I did something wrong here, but that's okay. So what I'm expecting back is from here is essentially a list of all my repositories on GitHub. And I think I rewrote this right before, which is something you shouldn't do. But okay, so this is a way that I would make that server call. So essentially what I'm saying is make the server call, and then whenever that information comes back, here's what I want you to do with that. But as we were saying earlier with the asynchronous issue, JavaScript's going to keep on going. So this is the way that you handle that sort of issue. So kind of taking a step back, callbacks are so useful because they allow me to tell JavaScript what I want to do with data before I'm actually executing it, or before I'm actually making any server calls or anything like that. And again, the reason for that is I don't have any control over how long that server call takes. I don't have any control over any of that stuff, strictly speaking here. So I get to tell JavaScript, go ahead and do all this stuff, and we'll be able to handle that well whenever it gets back. That's the other way to do it is with a object called fetch. It too is in the spec. And so fetch is what's called a promise-based. This is another way of handling asynchronous issues. Promises are just objects that allow you to do asynchronous programming. And this is, you'll see that this is kind of like the syntax that you would see. So I'm going to fetch to this particular URL endpoint. I'm going to say, okay, then I'm going to do this, then I'm going to do this, then I'm going to do this. A promise has this then method available to it, and it just makes it for very clean asynchronous programming. I think this should still work. So. Oh, I am not that smart because I'm not connected to the internet, so that's the reason I can't make server calls. So, but that's okay. So really all that means is here, again, same concept. JavaScript, here's what I want you to do with this data whenever it gets back from this server call. Promises, I think that it'd be better if you have any questions about promises, I'd be happy to go over any of that, but they are, like I said, a little bit more of an intermediate to advanced concept. Asynchronous programming is it's very useful. In Node.js, it's super useful. At my job, we actually transitioned a PHP script to a Node.js script that was making a bunch of server calls all at once, and we were handling it. PHP was handling it in a synchronous fashion. That job every night took all night to complete. When we changed it to Node, because of the asynchronous nature of JavaScript, it cut it down to just an hour or two. And so you're able to spawn off all these different workers to go and do all this work, and then you handle it whenever it comes back, and it doesn't have to worry about what's going on currently in the program after it sends off that work to be done. But again, callbacks are a great way to handle asynchronous programming. Promises are the sort of newer way to do that, and there's even other more advanced ways to do that nowadays. So I'm going to kind of just skip over that part real quick. Okay, so we've talked a lot about the first big use of JavaScript, which is making server calls. You're in the browser, you have an HTML page that's rendering something to the user, and JavaScript is used to make calls to go get data or take data from the user's interface and save that to a database or whatever it might be. The other major use of JavaScript is the actual interaction piece of the interface of the web page to the user. So there's a distinction to be made when we talk about what the browser actually has in memory is actually more than what is being rendered to the user. So we call that the DOM. The DOM is actually what is being rendered to the user in any given web page. So when JavaScript interacts with the DOM API through the document object, which I'll show you an example of, you are able to interact with that document object, or that API, but then you have to take it back to the DOM. So in other words, what you're rendering is different than what might actually be in memory. As you manipulate things, it could be different than what's actually in the DOM. There are newer frameworks that solve that problem for you, but in this particular case, you'll see a ton of this, and it's really, really important to, I think, learn this part of it because this is just the historic use of JavaScript. But so here I have a pretty simple little web page. I have a couple of elements on there, and then you'll see here I have a couple of functions declared in a script tag. So whenever I load this up, the browser is going to render all of these elements
all these HTML elements, and then I'm also going to have in this declaration this script tag of things available to me. You can see here that I use the document object to query the DOM to find the element that I want to manipulate. So in this case, I'm doing it by ID. And ID is, you assign a HTML element just that one value. So it's one for one. So because I know that it's only going to be one thing, I know that it's only going to return one element, and then I can change it. So if I have this, I can call that function, change the div contents, invoke it, and it changes the contents of the div. The other option is I can query it using this change list item color. Here I've listed out my favorite foods. And using this, I can use a class, which is just a set of elements that are all similar, presumably, to then get an array of all those elements and then manipulate those elements again. So I can call this function, change list item color, and it's going to change that element. Okay, I'm going to refresh that because the other thing I can do is I can assign these functions as click event handlers, so functions that get invoked on a particular action, in this case a click action on this element, and do different things. In this case, I can invoke the function clickyfunc, or I can invoke the function that I just called, which is the change list item color. So I have this button, clickyfunc, it's going to alert, hey, stop poking me, stop doing that. And then the same function that I invoked a second ago, I can also change that to red. So using this document object, I can manipulate what is actually being rendered to the user. That's an extremely important thing part of JavaScript to understand. That document object is exposed by the browser. It's very standard. And so everything that you see in terms of online examples and documentation are some variation of using that. jQuery, for instance, it's been the king of front-end development tools for a long, long time. And it's essentially just a pretty wrapper around this exact functionality. Whenever you say jQuery, the $, you're saying, get me this element, in the same way that you would say document get element by ID or document.get element by class name. And so with that, I think I'm done. So appreciate it. Thank you, guys.